Question 10 is coming from differentiation and also integration. At the point 4, -1 on the curve, the gradient of the curve is -3/2. It is given that dy dx is equal to x to the power of -1/2 plus k, where k is a constant. Part A, show that k is equal to -2. Now, gradient is always equal to dy dx. So, gradient is equal to dy dx. So this therefore implies that I will get, actually I will equate this one to x to the power of -1/2, then plus k. So since this is the point 4, -1, then x is that 4. So I will have 1 over the square root of 4, because this is 1 over the square root of x, then plus 4. K is equal to this -3/4, over 2. So therefore k is going to be equal to -3/2. This will be a half. So when it crosses, it will be minus. Now, -1.5 minus 0.5, that will be -2. So therefore k is equal to -2. As simple as that. Then part B, find the equation of the curve. So to find the equation of the curve, then we need to integrate. So y is equal to the integral of dy dx, which is x power -1/2. And then our k is a -2. So we just put it there like that, dx. When we integrate, we increase the power by 1. Then we divide by that new power. Of course, here, there is that 2 has gotten x to the power of 0. So when you increase the power by 1 and you divide by that new power, you will automatically get x. So we shall have x here and then plus a c. There is an arbitrary constant which was differentiated and then disappeared. So we need to find it out. There is a mistake here. This one has to be +1. Now, this one will be a half. So we shall have x to the power of 1/2. So if down here I have a half, this one will somersault and then the whole thing becomes a 2. So we shall have 2x to the power of 1/2 minus 2x, then plus c. So since this point is on the curve 4, -1, then our y is -1 and then x is 4. Then minus 2 again times 4 plus c. Then we shall have -1. First of all, the square root of 4 is a 2 times a 2. That one gives us a 4. So when it crosses, we shall have a 4. And then here, this is -8. So when it crosses, it's a plus. Now, this is -5. So 8 minus 5, we shall get a 3. That means c is equal to 3. So the equation of the curve is therefore going to be y, which is equal to 2x power half minus 2x, then plus 3. As simple as that. Part C, find the coordinates of the stationary points. Of course, you know that for stationary points, dy dx is equal to 0. So we shall get the dy dx, and then we equate it to 0. Our dy dx was given as x power -1/2, so we shall have 1 over the square root of x, then plus k, but k is a -2. We equate this one to 0. So 1 over square root of x then is equal to 2. When you cross multiply, I'll bring this one here, then I take the square root here of x, and then we can square both sides. So when we square both sides of the equation, automatically this one will be a quarter, and then this one becomes x. So they said coordinates. So that means we need to get the y coordinate also. So what will be the y coordinate? Now you go and substitute into the equation of the curve. Remember, we got it as y is equal to 2, then x to the power of 1/2 minus 2 of x plus 3. So if you got this one wrongly, there is no way you are going to get that answer, okay? So we shall have y equal to 2 into a quarter, then power half, minus 2 times a quarter. This is a quarter, then plus 3. Of course, this one is going to be a half, so times 2, that will be a 1, then minus a half here, plus 3. So 4 minus a half, that is 3.5. 3.5 is the same as 7 over 2. So meaning the coordinates of the stationary point will be a quarter and then 7 out of 2, like that. And then part D, determine the nature of the stationary point. Then we need to differentiate the second time. First of all, the dy dx was given as x to the power of negative a half plus k, which k is a negative 2. Then the second derivative is going to be drop this power and then reduce it by 1. So we shall have negative a half, then x power negative 3 over 2. Of course, this one will disappear. Now, for the x-coordinate of the stationary point we have gotten as a quarter, what will be the sign of this second derivative? So we shall have a half, negative a half into, this is a quarter, then negative 3 over 2, and then what do we get here? Negative 0.5 into a quarter is 0.25, then power negative 1.5. This one gives us a negative 4. This negative 4 is less than 0. So hence, maximum, if the second derivative is a negative, then this one here has to be a maximum.